Well, fun, fun, fun. I say that because we're getting ready to have to work a couple of problems between this example and the one next in the next video that's going to cause us to have to use a lot of our skills to solve these. And these are fairly lengthy problems. Students love long problems, I know. At least I hear them complain about it every now and then. But hey, we're mathematicians. We can handle it. So we're told here that line L contains points at 1, 2, x is 1, y is 2, and 5, 4. Construct a line perpendicular to line L through point 17. Then find the distance from P, that point 17, to the line L. Well, there's several things we're going to have to do. And this, first off, we're going to have to find the slope of line L, because I need to know the slope in order to begin to write an equation for the line perpendicular to line L. Remember, the slopes will be the negative reciprocals of each other. Then I'm going to have to solve a system of equations to find the point of intersection between the two lines. And then I got to use the distance formula to find the distance from point P to the intersection on line L. So let's begin by finding the slope of line L and then write the equation for line L. Are you ready? Doesn't matter if you are or not, we're going to plow through. All right, so slope is y2 minus y1 over x2 minus x1, and then that's the case, then I've got y2, I'm going to say is 4 minus y1, which is 2, we're using these coordinates right here, over x2, which is 5, minus x1, which is 1, and so 4 minus 2 is 2, 5 minus 1 is 4, and so the slope of line L is 1/2. Now I'm going to use one of those two coordinates, and I'll probably use the 1, 2, and we're going to write an equation for line L, because I'm going to need it when I solve for the system of equations. So let's see, I'm going to use point slope, so 1 minus 2 equals 1/2 the slope times x minus 1. Y minus 2 equals 1/2 x minus 1/2. And we're going to add 2 to both sides, so we got y equals 1/2 x minus 1/2 plus 2, which is 4 over 2. And finally, my equation for line L is 1/2 x plus 3/2. Now I need to write an equation for the line perpendicular. Let's call this line lowercase p. And I know that my slope, if my slope of the line L is 1/2, then the slope of this line P, we're going to say, has got to be -2. They got to be the negative reciprocals of each other. And so let's see what we want to do. I'm going to use point slope, and we're going to use this point right here. So then I'd have y minus 7 equals -2 times x minus 1. Y minus y1 equals the slope times x minus x1. We got y minus 7 equals -2x plus 2. And add 7 to both sides, and we got y equals -2x plus 9. All right, now I've got to solve the system of equations to determine the point of intersection. Remember, I got a line like this, and we've got a line, let's say, perpendicular. We know this point right here, that was 1, 7. And I got to find this point of intersection. And I can do that using a system of equation. I don't think I got quite enough room on this slide, so we're going to move to the other slide. But what I'm going to do, since y equals, on line L, 1/2 x plus 3/2, and on line P, I'm calling it negative 2x plus 9. Well, I can at least do the setup. I'm going to set this up then. I'm going to substitute this for y into that equation and solve for x. And so that would give me 1/2 x plus 3/2 equals negative 2x plus 9. And we're going to go to the next slide and solve for that. All right, so we said that our equations were 1/2 x plus 9, and we set that equal to negative 2x, no, 1/2 x plus 3/2, excuse me. It's easy to make a mistake on this when you got so many moving parts, plus 9, so you got to be careful. Okay, well, let's add 2x to both sides, and let's subtract 3/2 from both sides. So then I'd have 1/2 x plus 2x equals 9 plus 3/2 minus 3/2. Subtracting 3/2 from both sides. All right, let's see. So 1/2 x plus 2x, well, 2x is the same as 4 over 2, right? And so 1/2 and 1 over 2 plus 4 over 2 is, that would give me 5 over 2x. And 9 is the same as 18 over 2. So 18 over 2 minus 3 over 2 is going to give me 15 over 2. Now I need to divide both sides of this equation to solve for x by divide by 5/2 or multiply by 2 over 5. So then x is going to equal 15 over 2 times 2 over 5. Well, my 2's are going to cross out. Will give me 3. So x is equal to 3. All right, so now I need to take this 3 and substitute it in to this part of the equation, which was one of my original equations for the line. So let's do that and solve for y. So now we can say that y is equal to negative 2 times 3 plus 9. Well, y is equal to negative 6 plus 9, and y is equal to 3. So our point of intersection is 3, 3. And remember that our point off the line, or on the line that's perpendicular to line L, that coordinate was 1, 7. So I'm looking for the distance between 0.33 and 0.77, and that would be from that point of 1, 7 to the intersection of the line L, which I'm saying occurs at 3, 3. All right, so let's go here. Now I need to use the distance formula. Now the distance formula, if you recall, is x2 minus x1 squared plus y2 minus y1 squared, and then we're taking the square root of all of that. So let's then begin to plug in what we have. All right, so, well, let's just say that these are the number 1s, and these are the number 2s, and let's proceed. So then I've got 1 minus 3 squared plus 7 minus 3 squared, taking the square root of all of that. 1 minus 3 is negative 2, so I got negative 2 squared. 7 minus 3 is 4, so we got 4 squared. We're going to take the square root of all that. And so then we got the square root of 4. Negative 2 squared is 4. 4 squared is 16. And 4 and 16 is 20, so we got the square root of 20. And I could leave the answer like that, Although I do see here that this is the same, square root of 20 is the same as the square root of 4 times the square root of 5. And the square root of 4 is 2. And so I could also say that it's 2 times the square root of 5. Or I could even say, I could just take the square root of 20. Let's see what that is. Second x squared, 20, enter, 4.47, approximately 4.47. Well, all of that, that's the distance between that point, P, 1, 7, that is not on the line, to line L, and we found that by drawing a line or creating a line perpendicular, finding the equation, doing the systems of equations to find the point of intersection, then using the distance formula. We used a lot of skills. You might want to watch this again. Be patient and persevere.